The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.
Inverters a lot of times can just look like a product on a shelf, but at the end of the day, all these solar arrays are being financed and looked at from a financial perspective on the premise of, say, a lifetime of 20 to 25 years. So you have to have that back-end service to support those electronics through that life. And we have a really big workforce here in the U.S. dedicated to service support.
Are you speeding the energy transition? Here at the Clean Power Hour, our host Tim Montague bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
Today on the Clean Power Hour, three-phase string inverters that aren't always three-phase. I'm Tim Montague, your host. Welcome to the Clean Power Hour. My guest today is Evan Upshur. He's a senior account representative for Chint Power Systems. Welcome to the show, Evan.
Yes, thank you for having me. Excited to be here.
As we were talking in the pre-show, Evan, Chint has now rolled out a single-phase inverter, which is a big deal because you're best known, you are the #1 three-phase string inverter manufacturer in America for the last, I think, 8 of the last 9 years. But now you also are getting known for your single-phase product. So we're going to talk a little bit about that. But before we do that, Evan, tell us about yourself. How did you get into solar and why particularly inverters?
Yeah, so I think inverters is probably more of a coincidence than anything. I started in solar back in 2018, worked in a sales engineer role. So designing systems, working heavily in the sales process as well, locally here in Michigan. I was right here in the Great Lakes state and did a variety of work here and was really excited to maybe just become a representative of a manufacturer because there's a certain degree of innovation involved. And I've been known to be a little bit of a creative person. So doing things innovative, creative, things like that, that's right up my alley. And like the electronics field a lot. I grew up tinkering, as you could imagine, with electronics. I was involved in underwater robotics in high school, and I'm a musician, a lot of audio recording, electric guitar, things like that. It's all electrical. It's just been part of my life ever since I was really young.
Very cool. Yeah, manufacturing here in the Midwest, we are well known for manufacturing. It's not all good news, right? There's huge swaths of the Midwest that are now a rust belt because manufacturing left and went overseas or south of the border. But now it's coming back. And thanks to the IRA, a lot of reshoring and onshoring is happening in solar. But let's talk about string inverters. The string inverter is now displacing the central inverter in large C&I, small utility, and utility scale solar. Back in the day, you would have 1 to 10 megawatt central inverters doing all the heavy lifting on solar farms. And now you have these 100 kW to 350 kW string inverters that are replacing those central inverters for a variety of reasons. And largely it has to do with the OpEx, the operational side of that equation is more cost effective when you use string inverters because then you're just, if something needs to get replaced or fixed, you're just working on the suitcase, not the bus.
Right.
And you can move the machine with a couple of workers, not a crane. And that's convenient and faster. And you can store spare parts on site, right? Because they're not the size of a bus. But
exactly.
Tell us a little bit about your journey at Chint, why you've stayed at Chint. What do you think differentiates Chint, from your many competitors in the string inverter space?
Yeah, I think it comes down to company culture a lot. I think when an organization can grow a culture that's healthy for its employees, that trickles out to its customers. And I think a lot of our customers see that. It's like an inherent quality of good culture at a company, and it bleeding into its customers through innovation. But really, I think what's interesting about us, and I get this feedback a lot from our customers, is just the service side. Inverters a lot of times can just look like a product on a shelf, but at the end of the day, all these solar arrays are being financed and looked at from a financial perspective on the premise of, say, a lifetime of 20 to 25 years. So you have to have that back end service to support those electronics through that life. And we have a really big workforce here in the US dedicated to service, support, field service, technical support, phone support. It's all based here. So I don't know, it's rare. Certainly before I came on board with Power Systems, I was on the other side of the fence. And a lot of times it was really hard to get a hold of people. And we try to be different in that aspect here. There's a lot of people out in the field every day using our inverters. I think CPS is up to 20,000 plus sites out in the field now. So you got to have that back end support. And that's been probably the biggest plus in terms of what we're able to provide. And it feels good to be a part of that too.
Yeah, this is the way I explain it. There's a lot of good technology in solar. And yeah, some technology stands out, but it's in the string inverter space, there's a lot of good technology. But the people behind the technology are a major differentiator. And you have to have both. You have to have good technology and good service and support, and people that are easy to work with and are going to be there and answer the phone and get back to you to make your project move forward, whether that's a new project or a service project, whether you're retrofitting or repairing, whatever that is. And
Right.
and this is, go ahead.
I was just going to say, we hear that whole thing all the time, and it really is. It's a balancing act. You could have equipment out in the field that is free, right? But if there's no back-end support, the cost of it up front doesn't really matter anymore. And in a world where, like you'd mentioned earlier, there's so many people worried about operational cost, OpEx, and building these sites as cheaply as possible, that back-end service isn't always looked at. You have asset owners out here who are maybe taking projects and switching hands every few years. And so that back-end support doesn't really change. But I think as the solar industry kind of evolves and matures a little bit, folks taking on a little bit more accountability on that O&M side, the operations and maintenance, and making sure that these fields have service throughout them. I think it's evolving a little bit, but I think luckily we're seeing that more now. I think there's a lot of projects out there where maybe people don't care about O&M at all.
Yeah, O&M is becoming a big deal. And projects and portfolios of projects are, some of them, underperforming because there is a bit of a race to the bottom on the construction side of things. The bean counters want the project to get built for as little as possible, but that's a double edge because then it's not going to function as well or be as reliable as you want it to be. Right. So anyway, I would love to hear though, like, what is the journey that you take your customers on when you're in the sales cycle? Because there is an educational component to any sale, that helping people understand what it, and you could maybe just talk about one of your best-selling products like the 5060 or the 100 kW in string inverter, and what is it that you have to do to be?
Yeah, I think it's really just understand the project, what the project is, where it's at, how it's being built. There's so many different components of solar arrays in today's era of commercial three-phase and now single-phase commercial as well. For instance, you have solar carports, you have ground mounts, which could just be something in a field, you have roof arrays, and then on top of that, you have a variety of different roofs that you can mount solar on. You've got a variety of different carports and the location of those carports and how they're integrated electrically. And so in a best case scenario, you have a good feel for the project, where it is, how it's being built, the customer's involvement in the project, and just really figuring out and identifying what we have on our end that can fit as a puzzle piece inside that project. We've been, like you said, number one market share in the space for the last several years. And a good part of it's because of our product line is really versatile. You can do Delta or Y interconnection configurations. We even have some ways to design the site without a neutral conductor. And then a lot of our inverters can be used on roof mount or ground mount. So there's a really good, I think my job might be a little bit easier because our product line is so good, but really just understanding the project is key.
Can we talk about a project? You don't have to name the customer, but let's just talk about a project. You can talk about it generically. Let's say it's a 50,000 square foot flat roof. Yeah. That flat roof is what differentiates commercial from residential. You don't see a lot of flat roof in residential unless you go to certain markets like the Southwest. You do see some flat roofs in New Mexico, Colorado, Arizona, where there's relatively little precipitation. But for the most part, flat roofs are only found in commercial, and then they get very big. But 50,000 square feet is good. You could put a couple hundred kW on a 50,000 square foot flat roof. And we're talking three-phase though, right? In resi, it's all single phase. In commercial, in large commercial, like a 50,000 square foot and up facility, it's going to be three-phase.
Yeah, absolutely.
But what is it like if I'm an installer designing a project, which I've done dozens and dozens of times, using helioscope, for example, and I've grown to learn to specify one of 3 or 4 brands. Typically, it's a short list of brands that I'm going to pick from. And what is it that I'm designing for, right? I'm trying to get as few number of devices for one thing as possible.
Yeah.
Because that's just going to be quicker and easier and more efficient. So if I can use a 100 kW inverter, I will do that versus a 50 kW inverter, typically. Although,
and I think you're on track. You start at that sort of top-down approach and look at the basics. What type of service does the facility have, or what type of transformer they're tying into? Most of commercial and industrial projects, the low-hanging fruit is those medium-sized rooftops where you can put solar. Maybe there's not a lot of obstructed space up there. So just looking at the service, 480 volt is most common. Luckily, we have a bunch of inverters that tie in at 480 volts. So it's just an interconnection input right out of the inverter. And actually, this wire box behind me here is an example of that. So this wire box mates up with it's related to the 25 kW 208 volt, which is another voltage we offer, but it also does the 480 volt versions of the 36, 50, and 60. So you're looking at that, tying in at 480. Next, you would look at what really are the electrical code requirements. I'm not working in just the home state of Michigan here. I'm working across the entire Midwest and even past that at times. And so the code varies greatly and can dictate what we want. In fact, just about 20 minutes away from me on the other side of the river in Detroit is Canada. They have different requirements for rooftop up there that could even further expand your options of what you could use up there. So code is an important one. Luckily, code is evolving a little bit to make our solutions a little bit more adaptable to what's going on. But this would be a great product for a rooftop that size. It's got an impressive DC to AC ratio, meaning you can put about 180% of solar onto its AC nameplate. So for instance, if this is a 60 kW inverter, you could put, depending on the module, over 90 kW of DC on it, which gives you the ability to reduce your number of inverters. Maybe there's an interconnection cap where, say, 120 kilowatts is your AC cap. You can put more solar than 120 kilowatts on there to enhance the financials of the project.
The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more. I'm just curious, what is the scenario where you want to overstack. I don't know what the correct expression is. The DC, the amount of modules that you would attach to, like you said, a 60 kW inverter. What I think of is you're squaring out that energy production, right? You're clipping more in the middle of the day, right?
Yeah. So if you have a 60 kW inverter per code and NEC and everything, it's only allowed to produce that 60 kilowatt. And so the utilities look at that as a nameplate capacity. So this 60 kilowatt will never produce more than 60 kilowatt. But if you take 60 kilowatts of solar panels on a DC end and you put them out in, say, an October Midwestern climate, they're probably not going to produce 60 kilowatts. And so oftentimes you see people loading more DC kilowatts than the inverter has AC kilowatts to account for that difference in production. And there's also other instances where there's certain utilities that say, hey, we can't interconnect over 40 kilowatts AC. So you would have to say derate a 50 kW down to say 39 kilowatts, but we still want to have that big production of a big array. So say on a cloudy day, you're producing a lot more than the 40 kilowatts that you would interconnect into that anyway. The DC to AC ratio is an important thing in today's landscape where utilities are pushing back on how much you can interconnect into the grid, because a lot of times they're just really looking at the AC, not the DC. So you can go wild on the DC as long as your inverter allows for it.
Yeah, there's a couple of things. You have to think about the net metering rules. How much can you get credit for energy that you're feeding back onto the grid? And typically here in Illinois, in commercial, if you take the smart inverter rebate, you're not getting full retail net metering, you're getting wholesale net metering. And now that we're going through that transition to net billing, which impacts residential. But there's the net metering consideration. And then I think also just how much percent of the load are you trying to offset? If you can offset 100% of the load, then you might go to 110% of the load with the AC side. And then that DC to AC ratio, the one that I used, I guess, the most is like 1.2 or 1.25 to 1 DC to AC, but we now see quite a bit higher, sometimes 1.4. And you see a lot more of this than I do. So what are you seeing?
Yeah, it could vary completely too. The other thing, it doesn't matter how many solar panels you have, really. The other factor you have to consider is how are those solar panels being mounted? Are they at a low angle to where they're not as conducive in terms of the direction of sunlight? There's some pretty interesting concepts out there where racking might have the panels flat so you can fit more together in a smaller space. Those panels laying flat aren't going to be as productive as if they were, say, at a 25 or 30 degree angle. And to account for that, you up the amount of panels to account for it. Same thing in a northern climate. If you're up north, you're probably going to do some higher DC to AC ratios than if you were in the desert or something like that.
And you're working in that area, this is a quick aside, but where certainly in Illinois, for the most part, we're using trackers. But if you go north of Illinois into Wisconsin, Minnesota, or Canada, the benefit of a tracker will fall off and you'll start to see much more fixed tilt just facing south or maybe east-west.
Exactly.
And I never built an east-west system. I did see an east-west system when I was just in Oregon doing a training with OSEA. Shout out to the Oregon Solar and Storage Industries Association, great group of installers and affiliated professionals. But I love East-West. It's very clean. And that gives you, and that also gives you a more square production because you're getting good morning production and good afternoon production. But what other considerations does a developer or asset owner have when they're choosing technology? What are the challenges and opportunities that you're juggling with your customers that help them make a decision?
Yeah, there's a couple to pigtail off of, let's say like an electrical pun, but to pigtail off of like code, for example, rapid shutdown has been a really popular topic just because it's very invasive in terms of how you can design a system. Back in 2014, you wouldn't really have to do much to comply with rapid shutdown, you put the inverters up on the roof and you move on. And then you fast forward a few years into 2017 and so on. Then you're required to do module level power electronics. So putting something like an APS rapid shutdown unit on the back of every single panel. So you're adding complexity to the array, of course, cost. But one of the more recent updates with that has been UL 3741. So you can essentially eliminate module level power electronics. Caveat is if you have to put the inverter within a 1 foot boundary of the array. So there's a trade-off, but if the roof works for it, the trade-off is well worth it. Just to keep things simple and obviously more affordable, but simplicity, I think, is a really key, topic in that regard. And just trying to mitigate risks and just keep things as simple as possible for a 25-year lifespan.
Yeah. And I think this is something that especially residential installers that are doing light commercial and then growing into large commercial struggle to understand. They're used to working with, for example, microinverters in the residential space or string inverters with MLPEs. And now, and they think, oh, okay, rapid shutdown, I want to use an MLPE. No, you don't have to use an MLPE.
Yeah, you don't have to.
And the advantage of not using MLPEs is many fewer connections. Connections are potential points of failure. So think about that. Quicker installation, you're not installing all those MLPE devices. And then those devices themselves are a potential point of failure, even though they give you some benefit. Dealing with shade, module level monitoring, those are niceties. And certainly I understand in residential why a consumer might want to have that level of monitoring. But in commercial, we don't care so much about module level monitoring. It's more about, okay, if I can know when a string is down or an inverter's down, that's important to know and good to know, and we'll get that fixed. But I'm not looking, because I'm talking maybe millions of solar modules on my project. These projects get very big.
Yeah, exactly. It comes to a point to where it's really not conducive to have that level of detail. And I don't want to gloss over price, because it might not be the most important consideration for everyone, but price is important. If we're trying to push the solar, industry into the future, the idea is that the stuff, starts to get a little bit more affordable than the other way around. And the MLPE was really derived from like a safety standpoint, which is interesting because the new UL 3741 kind of took a different approach to give you that safety while reducing the amount of electrical points and points of potential failure. So it's a nice addition to have. The module level power electronics is certainly a good technology, and we respect its value and everything like that. But it's nice to have some variety there in how you can approach a rooftop design now.
Everybody wants options.
Exactly.
And so in our last few minutes together, Evan, what else should installers, developers, asset owners know about CPS and your portfolio? Do you want to talk a little bit about the single phase, or what's important for us to cover?
Yeah, really. And there's a lot going on. The inverters like the one behind me that have led to such a prominent market share for so long for Chint Power Systems, that product lineup is evolving. So everything's getting bigger like it has over the past 10 years. We're rolling out a lot of new inverters that are bigger on more of the utility scale side. We have our new 250 kilowatt, which we already have a 250 kilowatt, but it's 800 volt. Now we have another 250 that's 600 volts. A little bit more flexibility in terms of the equipment that you might need to source for it. 600 volt has been around a lot longer in the solar space than 800 volts. That's a little bit quicker to pick up, but the 250 is a single input, so you can design with it a little bit differently. It's got a separable wire box like a lot of our inverters have had in the past, so there's a good serviceability standpoint with it. And then, like you keep mentioning, the single phase product is pretty exciting. When people think commercial and industrial, even, a lot of people might not jump to even think of something single phase, but in fact, it's out there a lot. And I don't think a lot of people have looked at that. It's an interesting standpoint, but I grew up out in the country, and a lot of the farms out there, a lot of the little box stores, a lot of the rural businesses, they're not really three-phase, but they're commercial. They use a ton of power, but they're not three-phase. So you can't use a three-phase inverter. We just unveiled a 12 kW single-phase inverter with an impressive DC to AC ratio to combat that. And now you're seeing them go in at farms and box stores and everything already. It's pretty exciting to be able to fill that niche, because we don't want to forget about rural America. Solar really is at a point to where it's affordable for everyone, and rural projects included.
Yeah, that's a great point. I see a lot of solar on farmsteads in the Midwest. And it's still early days. It's still only a fraction of the farmsteads that have solarized their facilities. And these are 10 to 50 kW projects, generally, unless there's a bigger grain storage facility there where they're running dryers and that kind of thing.
But that's a perfect example. And this is the time of year for it, where luckily we've had a pretty dry harvest season up here in the Midwest. Other years, it's not like that. And they're running the grain dryers really hard. And it's a huge load on the electrical demand.
So I would encourage our listeners to check out CPS at the next trade show you go to, or reach out to Evan. How can our listeners find you, Evan?
Yeah, I'm on LinkedIn, of course, so they can find me there. And usually at a lot of the local trade shows, you'll certainly recognize my face if you're at any networking event or solar trade show throughout the Midwest.
Senior Account Manager Midwest for coming on the show. I'm Tim Montague. Check out all of our content at cleanpowerhour.com. Please give us a rating and a review on Apple or Spotify, and reach out to me on LinkedIn. I love hearing from my listeners and connecting with you. I love to get your suggestions for guests as well on the show. So with that, I want to say thank you, and let's grow solar and storage. Take care, Evan.
All right. Thanks a lot, Tim.
The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.